File handling in Python involves opening, reading, writing, and closing files efficiently. Mastering these techniques is crucial for data manipulation and storage. Exception management ensures robust code by handling errors gracefully, preventing crashes. Understanding try-except blocks and custom exceptions enhances program reliability and user experience. File handling in Python is essential for managing data storage and retrieval. This chapter will cover the basics of opening, reading, writing, and closing files, providing a foundation for more advanced file operations. Understanding these concepts is crucial for developing efficient and reliable applications. File handling is crucial for persistent data storage, allowing critical information to survive program termination. Python's open function supports various file access modes, enhancing application robustness. Proper file management ensures reliable, production-grade applications that handle data safely and efficiently. Our mode is for reading existing files, raising file not found error if absent. U mode writes, overwriting or creating files, risking data loss. A mode appends, preserving existing data. B flag handles binary files, used with modes like RB. X mode exclusively creates new files, failing if they exist, preventing overwrites. Using R mode, ensure data.txt exists to read its content. W mode overwrites output.txt or creates it anew. A mode appends to log.txt, preserving existing data. RB mode reads binary data from photo.jpg. X mode creates config.txt exclusively, failing if it exists. The with statement ensures files close properly, even on errors. File operations are essential, but can be tricky. In read mode, ensure the file exists to avoid errors. Write mode overwrites data, so verify paths to prevent loss. Append mode is safe for adding data without deletion. Exclusive creation mode fails if the file exists, ensuring no accidental overwrites. Proper file handling prevents data mishaps. Reading files with read loads the entire content into memory, which can be inefficient for large files. Consider using readline, or iterating line by line. Writing files in write mode replaces existing content, so verify paths to avoid data loss. Appending files in append mode adds new data without overwriting, useful for logging. File not found. Error arises when trying to open a non-existent file in read mode. Permission error occurs due to insufficient access rights. A directory error is triggered by incorrect path specifications. I/O error or OS error covers general input/output issues like disk space exhaustion or hardware failures. Python 3 unifies many input/output exceptions under OS error with specific subclasses for precise handling. When a program attempts file operations, Python detects errors like missing files or permission issues. Using try-except blocks, these exceptions are caught, allowing the program to recover gracefully. This ensures the program can continue with fallback logic or provide informative error messages to the user. Python exceptions occur during runtime in syntactically correct code, triggered by conditions like division by zero or missing files. They can be anticipated, caught, and handled programmatically, allowing programs to continue execution gracefully. Understanding the distinction between syntax errors and exceptions is crucial for effective error handling and defensive programming. Syntax errors occur during parsing, violating Python's grammar, like missing colons, and must be fixed before execution. Exceptions, like zero division error, arise during runtime in correct syntax, triggered by conditions such as division by zero. They can be caught and handled, allowing programs to continue smoothly. This distinction is vital for effective error management. File handling in Python can trigger specific exceptions. File not found error occurs when a file is missing, often during read operations. Permission error arises from insufficient access rights, such as read-only files. ISA directory error indicates a directory was mistakenly treated as a file. I/O error, now an alias for OS error, covers broader input-output issues like disk or network failures. Handling exceptions in file operations is crucial for robust programs. Use a try block to attempt file operations. If an error occurs, Python matches it with an except clause, executing the first match. Finally, the finally block ensures cleanup, executing regardless of exceptions. Prioritize specific exceptions before general ones for effective error handling. In Python, the try block initiates file operations. If an error arises, Python checks each except clause sequentially. The first match executes, avoiding program termination. The finally block runs regardless, ensuring cleanup. Prioritize specific exceptions before general ones to ensure precise error handling.